Wait, there. So, preview and oh my gosh, is it going to go like really slow? Okay, so let's get started here. This is week 4. We're talking about, hi Jamie, can you hear me? Okay, good. Where's Portia? Where's Gabby? What? Yeah, I will. I promise. Okay, I'm going to get started. When she comes, I will let her in because I don't want this to go forever. Okay, so we're talking about Newton's laws here. Yes, she's in? I don't see her. Okay. Okay. So, Newton's laws of motion, and actually we're only talking about the first 2 laws. So, by the end of this, hopefully, you will be able to recognize inertial mass. And the one thing I want you to make sure that you understand is mass is not weight. Weight is the mass times gravity. So if you think about how much you weigh, if you weigh, I don't know, 100 pounds, then what you're going to do with that 100 pounds is if you divide it by 32.2, which is gravity on Earth in feet per second squared, you are going to get your mass. All right, mass and weight are not the same. We're going to learn how to apply Newton's first law, recognize his second law, and understand balanced and unbalanced forces. All right, so some vocabulary for you guys. Inertia. Inertia is the tendency of an object to resist changes in its state of motion. So inertia is you just standing still, okay? You are not, if someone tries to push you and you don't move, that is the tendency of an object to resist changes. Acceleration. Acceleration is a change in velocity. It's also a measurement of how quickly an object changes speed, direction, or both. And velocity is the rate of change of position along a straight line. These are things you guys should already know. Okay, so wait, let me make sure. Okay, so Isaac Newton, we're studying his laws of motion. Anyway, this is some background about him. He was an English scientist and mathematician, famous for his discovery of the law of gravity, and also the discovery of the 3 laws of motion. He published a book, Mathematic Principles of Natural Philosophy, which some people don't think is philosophical, however. No, just, I think you know what acceleration is, Portia, and I think you know what velocity is. You can look up inertia. If you want me to, I can go back at the end. All right. So there's a picture of him, very cute. And this is just one of his sayings. Just thought I'd just put that in there to add visuals, right? Okay, so these are Newton's laws of motion. Number 1, The first law, and these you really should know. You should have these written down somewhere. So an object in motion tends to stay in motion, and an object at rest tends to stay at rest unless acted upon by an unbalanced force. And an unbalanced force is a force that pushes or pulls, that there isn't something on the other side of it pushing or pulling back. The second law, force equals mass times acceleration. It is pretty simply just this. Force equals mass times acceleration. That's his second law. And his third law, which is we're not going to do in this video, but we will learn it next, is for every action, there is an equal and opposite reaction. So we'll learn more about that later. So an object at rest tends to stay at rest. An object in motion tends to keep on moving, unless you have an unbalanced force. So basically it means that this object is going to keep on doing what it's doing. All right? If it's sitting still, it's going to remain still. If it's moving, it's going to keep moving at a constant velocity. And why don't you guys write in the chat box there, and you can write down on paper if you want. It's okay. What does it mean for it to have something to have a constant velocity? Good. It just keeps on going. It's not accelerating, not slowing down. It is changing position, but it's steady. That's right. And it moves with the same speed and direction. And that's exactly what constant velocity means. And it takes some force to change the motion of an object. And that force could be the brakes applied in a car. It could be if you're pushing a book or a piece of paper across the table. It's the friction between the paper and the table, or the book and the table, that slows it down or makes it stop. So what is meant by an unbalanced force? I just gave you a couple examples. So the forces on a book are balanced. So that's why it doesn't move. The table pushes up on the book and gravity pulls it down, and those two things are balanced. And so your book or your pen or your computer on your table there will not move because those forces are balanced. So if the forces on an object are equal and opposite, they're balanced. The object experiences no change in motion, and if they are not equal and opposite, then they're unbalanced, and then things begin to move around. So some real life examples. I guess think about this. A soccer ball is sitting at rest, and it takes an unbalanced force of a kick to move it. So what about people playing with tug of war? If they're both pulling at equal forces on a rope in opposite directions, then nobody's moving, right? They have equal force. It's a balanced force. So Newton's first law is also called the law of inertia. So real quick, inertia. Who was the first one to do experiments that actually had to do with inertia? You guys should have read this or watched the video, the first lesson. Did you guys do any lessons in week 4? No. Nice. Galileo. All right. Galileo was the first one that actually gave a definition to inertia. Way back when, Aristotle did some work with it, but he didn't come up with he didn't have the correct kinds of experiments. But Galileo came up with some really good experiments, and he's the one that gave the definition to inertia. And this is what it is: the tendency of an object to resist change in its state of motion. So the first law states that all objects have inertia. You have inertia. The table has inertia. Everything has inertia. The more mass an object has, the more inertia it has, or the harder it is for you to move it. So if you're looking at a train, whoops, hold on, here we go. And it begins to pull a long line of cars that were sitting at rest. And this is the same thing if you think about, I guess, starting to pull a book across the table if you had a rope attached to it. The very beginning, you kind of pull, you start out pulling really slowly, and then you pull harder and harder and harder, and finally it starts to move. That is some real life examples of something with inertia, great deal of inertia. Even though your book doesn't have a lot of inertia, it still takes that change in motion, or that force, the unbalanced force, for it to move. Okay, but once you get it moving, it's pretty easy, right? Think about a big, like a sofa or something like that. Really takes a lot of power to get it started, but once you get it started, you can keep it going. On your way to school, a bug flies into your windshield. And since the bug is so small, it has very little inertia, and you just really don't feel it. It doesn't stop you at all. You kind of stop the bug. All right, so if objects in motion tend to stay in motion, why don't they keep moving forever? It's because they have an unbalanced force acting on them. So, hold on, there we go. Friction is one of those unbalanced forces. It helps you to stop or slow down. The tires on your car and the road, there is that type of friction between them, or the brakes on your car and your wheels, that help you to stop. And the same thing happens when you throw that ball up in the air. That force of gravity is the unbalanced force that makes it stop and change direction. So in outer space, far away from gravity and any source of friction, a rocket ship is launched with a certain speed and direction. Would it keep going in the same, it would keep going in the same direction and at the same speed forever, because there is no friction, there is no gravity way out there in space. And really, for the rocket ship to leave the Earth's atmosphere, that's when they use up all their fuel. But once they get out into space, all their fuel is gone, and all they're doing is just moving and moving. There's no rocket fuel involved anymore at all. It's all just like when you, there you go, sliding across a floor on your carpet. Okay. Now, once you get up there, what they do is they stop the fuel. They turn it off. It's like turning off your car when you go up into space. Once they get out of the Earth's atmosphere, they sort of turn off the rocket, I guess, if you want to think of it like that. And then when they want to get back, they turn it back on, and then they can come back. Does that make sense? Yes, you would be able to come back, I promise. Okay, so the second law of motion, and it's just force is equal to mass times acceleration. And acceleration is the measurement of how quickly an object is changing speed. There's no gravity, but they're going to have a force of the engine turning back on. So when they turn on the engine, then all of this fuel and stuff comes out of the back. You know what I mean? Kind of like when you turn on a car. Okay. I hope that makes sense. And if it doesn't, we can talk about that a little more. Okay, so what does force F equal ma mean anyway? The force is directly proportional. So for you guys in math, directly proportional, this is very important, to mass and acceleration, mass times acceleration. So imagine a ball has a certain mass moving at a certain acceleration. The ball has a force. Now, if you can imagine the ball twice as big or double the mass, so instead of it being, I don't know, like a baseball, now it's a big volleyball. Hopefully that's double the mass. But you're going to keep the acceleration constant, says that this new ball has twice the force of the old ball because you've doubled the mass. Now imagine the original ball is moving twice the original acceleration. Again, the ball is going to have twice the force because it's moving at twice the acceleration. So if you double the mass, you double the force. If you double the acceleration, you double the force. What if you double the mass and the acceleration? Whoa. Hold on. What happened? That happens to me all the time. Okay. So what if I double the mass and the acceleration? Then I'm going to have 4 times the force, right? Or quadruples. So what if I decrease the mass by half? How much force would the object have now? Yes, Jamie, good. It would have twice the force. No, it would have half the force, sorry. Okay. Basically means that the force of an object comes from the mass and its acceleration. So something very massive that's changing speed very slowly, it can still have a big force because it's really, really heavy. So it has a big force. Something that's really small, that's changing, has a big acceleration or a high acceleration like a bullet, has a big force, okay? Those things are directly related, force and mass and acceleration. All right, that was so much fun. Here's our review. Newton's first law, what is it? Inertia. It is. It has to do with inertia. That's right, Jamie. What is it? I'm going to wait till Shay quits typing and then we'll show you. Think about it. What's the first law? Very good. That is right. Objects in motion tend to stay in motion, and objects at rest tend to stay at rest unless they are acted upon by an unbalanced force. What about the second law? This one's easy. What's the second law? Yes, equals. That's all it is. Force is equal to mass times acceleration. And that is it, ladies. And I say ladies because there's only 3 ladies here. All right. So you guys have any questions for me? All righty then. You are free to go, and thank you so much for coming.
My Adobe Connect didn't work. I even restarted my computer and tried it again, and it still wouldn't open. I just don't know what's going on.
Well,
It's because I said it was working okay.
Oh yeah.